Hello everyone. We have been studying polygons in Unit 8 for quite a while, and one of the things that we're going to cover today using Geometer Sketchpad is how to find the sum of the interior angles of a convex polygon. So what I want everyone to do is I want you to have your palette open in Geometer Sketchpad, and let's go ahead and make a few basic shapes. Let's start off with a triangle, and you can make any triangle that you wish. And then let's make a four-sided figure, or quadrilateral. Okay. And from here, let's make a pentagon. And you can make anything so long as it is convex. That means is that anything that does not create a instance that looks like, oh, say, this, right? We don't want that. That would be concave. So convex polygons. And also, we want them to be irregular. That is that we want to be probably as funny looking as possible, simply because that's going to prove our theorem even more, or prove what we need to go ahead and improve here. So, that said, let's do something that we've been trained to do before in the past, and let's measure some angles. So here we have our triangle, right? So our triangle, we know that has 180 degrees, but let's not take our word for it. Let's measure all the angles in the triangle, okay, and prove out that they're going to be 180 degrees. So if you look, we're doing the same process that we did in class today, where we're going to go ahead and put the vertice, okay, as the middle tap. That is that we'd go, if I want to measure angle C, I'd go A, then C, then B, and to go ahead and put the measure of the angle here. Now, to prove that these all equal 180 degrees, remember that we could go to our measure, actually I take that back, number, then calculate, and we could click on these guys and go this plus this angle plus this angle equals, and you can see that they equal 180 degrees, which is terrific. So all the angles of a triangle equal 180 degrees, and this should be no surprise to us because we've been studying it. Now, we have a quadrilateral, which is going to go ahead and probably be a little bit predictable for us because we studied also that quadrilaterals earlier on in the course that have 360 degrees. So what we want to do is that we want to measure all the angle lengths, okay? And I'm going to do so quickly here, and I want you to do the same when you have your palette open, okay? So here are these angle lengths, right? Oops. And I go E, F, G. And likewise, I need to get that last one over here. And angle G of the quadrilateral. Oops, missed it. And you can see that now I have all those angles measured out. Now, one of the things that we want to make sure that we have done is the fact that these all add up to a 360 degrees. And so, let's go calculate, and let's add them all up. There's this one, plus this guy over here, plus that, and plus the left bottom corner. And you can see that the interior angles are going to equal 360 degrees of quadrilateral. Okay, now, here's the deal. Why is this important? What is the correlation between these two? And if we look, the reason why it's always going to be 360, and you can move this around as you wish to go ahead and see in real time, no matter what that angle is, as long as it stays a four-sided figure, all the angles are going to equal 360 degrees. And the reason why is that if I were to, for example, create something called a diagonal, you notice that it's actually two triangles where you add up all the degree measure themselves. Okay, and so there's, just like one triangle is 180 degrees, this triangle's, right, those angles plus all these angles right here have to equal 360 degrees themselves. So that would be like two triangles. 2 times 180 is 360. Okay? Now, the same thing could move on to the pentagons and the sesagons over here, the six-sided figures. So what we want to do is create, okay, go ahead and measure these angles out. All right, and oops, I don't know where that put that. There's angle I. Okay, and while I'm doing that, we could go ahead and you could be doing the same thing here. I don't think it allows me to skip right to that. So it's a little bit of a long process as these figures grow larger. Okay, oops. Grab the point instead of the angle there. And we could go ahead and make a prediction in our head as we're calculating all these angle measures on what the interior angle measure of this pentagon that we're working on right now is going to be. So if we looked, rather than just telling the computer to measure all the angles right away and say, hey, you know, just give it to me, let's use the fact that we went ahead and we had one triangle for 180, two triangles that are 360. Let's create some diagonals and make a prediction first and see what the computer has to say about all the interior angle measure. So I'm going to go and create this diagonal here, and I'm going to create this diagonal here, and you notice that we have three triangles then. So with three triangles, would it make sense that we would count by 180s, starting first with the regular triangle 180, 360, and if we added, oops, sorry about that, added 180 degrees more to 360, we would achieve 540 degrees of interior angle measure. Let's confirm this by using our number function and then calculate. And it didn't want to give that to me. Alright, so here we go. And that part, I didn't want. I accidentally clicked on that. I seem to like that angle. So let's go ahead and click these on. Angle J plus angle HIJ plus angle LHI plus this angle over here plus this angle equals 540 degrees, as we predicted. Why? Because it's 180 plus 180 plus 180 will equal 540 degrees. Now, what I want you to do is that you can keep going, and for your assignment, what I would like you to do is continue this and see if you can come up with a formula. Okay, and what I want you to do is, instead of just measuring out all the angles using the computer, your assignment is going to be this, is to create a formula for the sum of the interior angles in a convex polygon based on the number of sides, number of sides that polygon has. Okay, and what I want you to do is I want you to write the formula in a text box like this, and I want you to email that to me at denplots the email that we use all year, at mac.com. Okay, and I want you to name this the interior angle exercise. Okay, so again, to review, what we did in this video is to go ahead and find out what's the relationship between the triangles, okay, or just a standard triangle, and breaking a convex polygon into triangles and determining the sums, right? The sums of the interior angles, okay? And this seems like it would be fine and dandy to go ahead and just keep adding 180, but what if your polygon had 150 sides? What would the interior angle measure be then? How would you go ahead and create a formula for that? Consider the extreme. Okay, I look forward to your answers, and we'll review this topic when we resume class tomorrow, and I will have a printout of the best answer so we can use that for our notes on our exams that are going to be coming up in the next week or so. So anyhow, thank you for listening. Come on in with some good questions tomorrow. Thank you.